engineers, because you are giving us the fundamental principles, and then after we are implementing it. So ultimately, those who are engineers, happy Engineers Day, and those who are science people, for for all of you also, it's a very important day today. And I'm happy that today there are faculties from computer science department, and then information technology department, and applied electronics. And that's why this topic is very, very suitable, because Internet of Things, I normally say that Internet of Things is a marriage between different disciplines like electronics, computer science, and mechanical engineering. So it is a kind of an interdisciplinary course where all engineers should and all science people should work together to give the fruitful outcome, right? So today we will discuss about the Internet of Things. My slides are changing on the screen sometimes.
Yes, sir, it is changing.
Okay, it is changing. Fine. So this is our session outline. So we will have a brief overview of IoT architecture, and then different IoT elements like the sensors, and then what are the IoT protocols and devices. We will be also looking at few hands-on on Arduino programming for Node MCU. Then we will have some demonstration of device control using mobile application. So I will show you few applications with help of your mobile app. You can control the devices. Then using a web application, how to control the devices. And then in the Internet of Things, very important is that we will be using a cloud. So today I will be demonstrating ub.cloud, in which we will upload the sensor data on the cloud. So this is actually today's brief about the session we will try to cover. And in between, if you have any questions, you can simply unmute your microphone, and then in between also you can ask if you have any doubt, any questions about any point. So first of all, let us look at what is the Internet of Things. And I am sure that all of you are aware of Internet of Things. We as a human being, we are using internet every day. We are using all the internet applications, emails, and all that. But now scenario is changing. Now also, things are also want to use the internet. So in a IoT, basically, we provide network connectivity as well as computing capability to objects, not only a human being, but all the objects will also utilize the internet. And that means we want to provide a connectivity to different objects. So the objects can be anything, like different objects are shown in this picture. Bicycle is shown, keys shown, then different types of sensors can be given internet connectivity. So the different objects, even the fan is shown here. This fan is there, motor car is there. Different objects are microwave oven, washing machine, even LED light. So all these objects, internet connectivity will be extended to all these objects, and all the sensors, actuators like servo motor, stepper motor, and all that. We are providing connectivity to all the objects, everyday items. So they can also participate in exchange of information. That is the basic idea of Internet of Things. So we are basically providing internet to different objects. And that's possible because in IP version 4, the number of devices were limited, but now in a latest version, IP version 6, actually we are having a lot of addresses are possible. So we will be able to provide connectivity to all the objects. So in IoT, actually, we are extending this network connectivity and computing capability. It is also extended to the objects. So that is the basic idea. And if we would like to start with, then suppose if you want to provide a connectivity to different objects, normally we start with a sensor. So we'll have a different types of sensors, and the sensors data can be communicated to the cloud system, so that that sensor data you can monitor anywhere from the world. So once you upload it in the cloud, you will be able to view and monitor it anywhere from the world. So that is basically we want to transfer the data from sensor to the cloud system. And to do that, actually, we require so many things in between. So these are the sensors actually we would like to connect with the internet. So there are maybe a different, depending on the different application, like we have a chemical and gas sensors. Then we have a acoustic and sound and vibration sensors. So we will have a different types of sensors here, which we would like to connect with the internet. So for a chemical industry, this is very useful. Even for for a alarming systems. Suppose there is a gas leakage is there, and if we want to know remotely whether there is a gas leakage is there or not, or whether there is any problem in a chemical, then we can use those type of sensors and connect those sensors with a cloud, and remotely we can monitor it. Acoustic, sound and vibration sensors. Then we may have a humidity moisture sensor. We would like to know the humidity of different places. And this is very important in case of agricultural. Whenever the crop is there and we want to store it, it should be stored at particular humidity and temperature. So for that, actually, this is very useful. And it's better that if you can control this temperature and humidity remotely, anywhere from the world, so that you can monitor. And not only that we monitor, but we can also control that humidity and temperature with help of the actuators. So, but for that, actually, we have to collect the sensor data, and then only we will be able to correct it, right? So initially we will collect the data from all these sensors, and then we will process it with help of a microcontroller, and then we give a signal to the actuators so that this condition can be maintained. Similarly, there are position, presence, and proximity sensors. So if you want to keep a watch on a movement on a particular, let's say there is a center called, where is some nuclear activities going on, and we don't want to allow much movement there, so then you can set that proximity sensor, so it can keep watch on the movement at that particular places. Or at any important places where you want to restrict the movement, then you can put the proximity sensor, and then remotely you can monitor that how many persons were in and out during a day at that particular place. Then we may have a machine vision and optical sensors, acceleration sensor, tilt sensor, and people are using in a Samsung Health application. You have a record of all, how many steps you walked today, how much cycling you have done. So for that purpose, this type of sensors are very, very useful. So ultimately, Samsung Health application is taking data from our sensors which are present in our mobile phone and transmitting it to the cloud. And then it shows you entire record with a graph and everything easily. Okay. Then there are electric and magnetic sensors, leaks and levels. So basically, we would like to check whether there is oil leakage is there or water flow in a water leakage is there. Sometimes we would like to measure the water levels, liquid levels. Then those sensors are very, very useful. These sensors are there, but in IoT systems, basically, we are trying to connect all these sensors with the internet. Then force, load, and torque sensors are there. So ultimately, we are trying to give internet connectivity. Am I audible? Is it okay?
Yes, sir, you are
Yes,
audible.
Everything is
we are
fine,
talking about like Internet
audible,
of
and the
Things.
slides are also visible, right?
Yes, yes,
Yes,
yes, sir.
Okay, fine, fine. Oh, no problem. So all such sensors, actually, we would like to give internet connectivity to all these sensors. That is a basic purpose of Internet of Things, because once we have a data, we can process it. If you do not have a data, then how to process it? So first of all, to collect the data, the sensors are very, very useful. So to transfer the data from sensor to cloud, there are various cloud computing services we will be using, because there are many companies which are providing cloud services. Like Microsoft is there, IBM Cloud is there, Amazon Elastic Compute Cloud is there, Citrix is there, Joint, Bluelock, Verizon, Salesforce, Rackspace, Google Cloud, ThinkSpeaks, uh, Drewsoft, NetMagic, UB and many other. If you find, just Google it, that cloud services. And many of them are free actually for the students actually, so you can use it. So today we'll be demonstrating the UB dots. Those who have a MATLAB license, they have a also by default, ThinkSpeak is providing access free of cost. Those who have a MATLAB login, user ID and password. So, and in most of the cases, the student evaluation versions are free for limited capabilities. So maybe that they will not give you entire space or some limitations. For example, ThinkSpeak will allow sensor data at interval of 15 seconds only. If you want to send at every second, it will not allow. So for a free version is having some limitations, but for doing the practicals, experiments, all these clouds are available to us. And
Sir,
there are,
I had a doubt.
yes,
Am I
yes, please.
audible?
Yes, yes,
Yes,
audible,
sir.
audible.
So when we are talking about Internet of Things, it doesn't compulsorily mean like we have to connect the objects to the internet only. Like radio waves on satellites can also be used.
Yes, yes. So it is a kind of a heterogeneous network. So just I am coming to that point, what kind of networks we can use. So you can
Okay,
use
sir.
heterogeneous kind of a network, yes. So IoT infrastructure services are basically a few examples I am talking about is a ThinkSpeak and Zively are actually useful to store the sensor measurements. So whatever the sensor data, and on a ThinkSpeak, there are various public channels are also available. Just you can, the public channels are the channels where you can get the data freely. So people have put the sensors at different places and they are continuously uploading data onto the ThinkSpeak, and they have made the data publicly available. So some weather stations are publicly available so that you can get the data directly from there and use it for some research work or for some monitoring purpose. You can always use your own sensors to connect data to ThinkSpeak, and you can create your own public and private channel on the ThinkSpeak. But whatever, if you create a public channel, it will be available to all. So your sensor data, other people can also use it. Twitter allows to objects to talk humans and receive commands. So all this I have given a facility. Yeller enables remote access to internet connected devices, and JPR and IFTTT allows the mess up of web services. So these are the different IoT infrastructure services. For a commercial application, it is paid, but for a student, actually, it's free of cost. So this is what I think your question. This will answer your question. That this is actually entire architecture of IoT system. So we have a sensor layer available here, and in this sensor layer, we have different sensors. Maybe a GPS sensor, electrochemical sensor, photoelectric sensor, RFID, gyroscope, electromechanical, etc. Or different sensors are there. It will collect the data. Then in a level one system, sometimes within a home, suppose in a home automation system, within a home you want to control. Then in that case, your local LAN is sufficient. Need not to send the data from sensor to cloud, because you want to monitor it locally and you want to control it locally with help of your local Wi-Fi or local Ethernet. Then in that case, sometimes you may not require to send the data to the cloud system. So in today's hands-on session, I will show you that also. I will connect my hardware with a Wi-Fi and will try to control some device. So that is a level one system in which we are not using any internet. Only if local Wi-Fi is available, using Wi-Fi access point, we can perform the job. But that is a level one IoT. We are not using fully the internet in that case. Then sometimes if Wi-Fi is not available and if you have a Bluetooth connectivity, then locally we can control the device, or locally we can collect the sensor data, process it, and send a signal to the actuators for the controlling. So we can use either Bluetooth or a Zigbee or a near field communication like NFC, so which is known as a personal area network. So if you have a personal area network also, then you can implement the level 1 IoT systems. So LAN or PAN we can use for it is only for a local control. That means remotely. So if you are located at Nagpur and if I am sitting at Rajkot, it may not be possible for me to control the devices available at Nagpur using LAN or PAN. So if I want to control the devices from Rajkot to Nagpur, I have to use the cloud system. So in that case, I have to go for a wide area network. So in a wide area network, there may be, as you told, a satellite, then it may be fiber optic or LTE, that is 3G, 4G, 5G, etc., wireless communication systems. UMTS is also part of it. So you use all these internet systems and communicate your data, which is coming from sensor to the cloud system. And once the data will reach at the cloud, anywhere from the world, you can access that data and you can create for any application, you can use it. The application layer includes agriculture, consumer, healthcare, transport, infrastructure, industrial, military, different IoT applications are there. So that is a part of application layer. So starting from sensor layer, then a gateway and network layer, then management service layer, and then application layer. So most of you must be familiar with OSI layer. So some of the layers are merged here together. Normally there are 7 layers are there, but in IoT systems, some of the layers are merged together. And as you can see here in this figure, that it is a heterogeneous network. Different types of systems are there. And ultimately, our point is to communicate the data from sensor to the cloud anyway. Either you use Wi-Fi and then from Wi-Fi to you connect it to the gateway and then you connect it through internet and connect it to cloud. You use either Ethernet cable, or if you don't want to communicate with the cloud, you can control the devices locally like a Bluetooth or a Zigbee and NFC communication, right? So this entire picture of IoT architecture basically. Right? So do you have any doubt, any questions in this?
No, sir.
Everything is fine. Okay. So these are basically, again, it's a repetition of earlier diagram. It's basically elements of IoT where we have a devices, different objects and devices, and we have any connectivity. Heterogeneous connection is there, any connectivity in between. Then some protocols are there, COAP and QTT and all these protocols are there. Then there is a cloud system, and in a cloud we write some rules there, that if temperature is greater than certain degree centigrade, then you push this data. If it is less than this, and you push this data, some kind of conditions are written there. As well as there is a storage also. So, you will have continuous backup at what time, what date, what was the sensor data. So that storage is also provided by the cloud. Then cloud is also sending signal to our application. So you can, on your computer, on your mobile or laptop, you can view the data graphically. So that is also facilities provided. Today I will show you one cloud in which they are providing this facility. Not only that, it will also provide signals to the actuators, which is available in a local hardware, which is connected with a local hardware, so that you can control the actuators. So you have monitored the data, but now after monitoring, if you want to control that data, you can send the signals, control signals to the actuators. So all these are the elements of IoT. So important is the sensing. After sensing, communication, and that is also heterogeneous in nature. Different types of networks we are using in between. Then cloud for storage and analysis, and then after analysis, there is the application for the end user. So these are the three important sequence actually: sensing, then communication, and then cloud, and then after there is a application. So this is normal sequence for the IoT applications. Is it fine? If you have any doubt in between, please ask.
No, sir.
Okay. So IoT devices, now we will discuss different types of IoT devices. The role of IoT devices is to collect some data from the sensors, then process the data, send actuating signals to the actuator. So that is basic role of IoT systems. If the controlling devices are not connected with the internet, the system is known as embedded systems. So if you have a simple, microcontroller and you have connected sensors and actuators with that, then everything you are doing locally. So that is known as embedded systems. But when we connect these embedded systems with the internet, then that same system becomes IoT based system, because now your sensors may be at different places, your actuators may be at different places. So it becomes IoT systems. So you can control your devices anywhere from the world. You can monitor your sensors anywhere from the world. So this is very good hardware which you can suggest to your students. Arduino Nano 33 BLE Sense. So there are two versions are coming, BLE Sense and BLE IoT is coming. So in this hardware, there is a ARM Cortex M4 microcontroller is there. It's from Nordic Semiconductor, NRF 52840. This is a very good microcontroller. It has a 8 ADC input and it's a 12-bit ADC. So you can see 12-bit means it's a very good resolution. So that you can connect 8 sensors with this very small board. And it has a digital I/O pins. About 14 digital I/O pins are available with this board. So you can connect 14 different actuators with this board. Like actuators means your solenoid, relay, stepper motor, DC motor, all these are known as actuators. ADC inputs are useful to connect our sensors like your vibration sensor, pressure sensor, temperature sensor, humidity sensor. All these analog sensors we can connect with a ADC input. And it has a UART, SPI, and I2C interface. UART means Universal Asynchronous Receive Transmit. That is a serial communication protocol. SPI is another serial communication protocol known as a serial peripheral interface. And I2C is also serial communication protocol known as a inter-integrated circuit protocol. So these three interfaces also provided with this. It has an inbuilt Bluetooth module. And some sensors are also inbuilt like temperature, humidity, barometric pressure, gesture, light, proximity, microphone, 9x6 IMU sensor. So these sensors are already inbuilt. You need not require to interface it externally. If you require other sensor than this, then you can use these 8 ADC input pins to connect other sensors. Otherwise, these sensors are already available inside the board itself. It has a 1 megabyte of CPU flash memory where your program will reside. 256 kilobyte of static RAM is available. And digital current per input output pin is 15 milliampere. So this is you have to keep in mind. If you have a larger current, then you require some kind of a circuit like driver circuit you require. Like you can use this type of a transistor driver. If I am using this, then I can, my IO pin will be connected here to the base of the transistor. And my device, which I want to control, which requires a larger current, device I have to connect at the collector of this transistor. So this is the device. So if your device current requirement is larger than 15 milliampere, then you should use this type of a current amplifier in between. But if your device current requirement is less than 15 milliampere, like if you want to connect LED, LED will just glow within 8 to 12. more hardware. Slides are visible.
Yes, sir.
Yes, sir.
Okay, fine. You can see here, this is a Arduino Nano board is there. This board is Arduino Nano board. Just I will change the color of my pen. It's not visible. So this board is known as a Arduino Nano. Very small board is there. This is Arduino Nano plus Wi-Fi. So this is a Wi-Fi chip available here. So this is Arduino Nano plus Wi-Fi chip is given. So for IoT application, this board is good. Of course, it is Arduino Nano, but it is also having a Wi-Fi inside it. This is simple. So simple embedded systems, this Nano board is okay. And this is a Arduino Uno board, but plus Wi-Fi is also there. So you can use this for IoT system. Or some of you must be familiar with the Arduino boards. So this is the Arduino Uno plus Wi-Fi. If you use the Arduino Uno alone, it is a local embedded system. But if you connect Wi-Fi with this, then you can communicate your data to the cloud. So it becomes a IoT hardware. Then this is a Uno board. So again, a different version of Arduino. And this is the Arduino Mega board. So these are the hardwares. So normally people are using for IoT applications. And this is a very good board, Raspberry Pi board. So the advantage of Raspberry Pi board is that you can also connect a video camera. In previous board, we cannot connect video camera, but here also you can connect the video camera. So if you want to view the video remotely, then this Raspberry Pi will allow us. Otherwise, all other capabilities of earlier board, like controlling the devices, sensing the data, all these things can be done with help of a Raspberry Pi board. So this kind of a small computer. There are USB ports are available here, where you can connect different devices, like you can connect USB keyboard, USB mouse. This Ethernet port is given here, so you can connect this with Ethernet cable. Inbuilt Wi-Fi chip and Bluetooth modules are also coming in advanced version of Raspberry Pi 4.0. This is the earphone socket which you can use to listen the music. This HDMI port you can use to connect any HDMI display. And this is a micro USB port where you can connect plus 5-volt supply with help of a mobile cable, a charger cable. And this is the ARM processor sitting on the Raspberry Pi board, which is responsible for doing all the jobs. And this is GPIO connector available on the Raspberry Pi board, where you can connect the devices, actuators and digital sensors and all that. Only the thing in Raspberry Pi that inbuilt ADC is not available. So you require to connect ADC externally in Raspberry Pi. In Node MCU and other boards, Arduino Nano and all that boards, internal ADC is available. But in Raspberry Pi, the internal ADC is not available. These are few more IoT devices, like this is Zigbee module I was talking about. If you are interested in communicating the data locally within a range of 100 meter, then Zigbee is a
one
good.
question, please.
Yes.
Sir, is this Raspberry Pi easily available in the market?
Yes, it is available. Even you can purchase it online. You can order it on Amazon also. So it's available easily, and it will reach to you within 2-3 days only. And purchasing online is better because the cost is less. It's available with a low price. If you go in a market and try to purchase it, sometimes it is costly. But if you order it online, it's very easy. So it is easily available.
Okay, sir.
But if you are going to purchase it now, purchase the latest version, because it is having a both Wi-Fi and Bluetooth, both are there. If you purchase the earlier model, Raspberry Pi 3, then it will not have a Wi-Fi and Bluetooth module. And there is no difference in cost. Mostly, the difference is only 500 rupees. The old version is available for a 2,500, and this new version is available for 3,000. So with a cost of only 500 rupees, you will be getting both the module inside the Raspberry Pi. So that is very useful. So you can suggest your students Raspberry Pi 4.0, they can purchase, and it is easily available.
Sir, one more question.
Yes, yes, please.
Sir, how to connect these devices to computer and how to get data in computer?
Sure, sure. Today I will demonstrate that also. So initially I am giving you just a briefing, and then after I will demonstrate that how to connect and how to program all these devices, right? That I will also
Okay,
demonstrate.
Okay, thank you.
So this is another device called Node MCU device. So I will be demonstrating this device today. This is a very good device. It is costing around only 300 rupees. So in 300 rupees, it is having a microcontroller inside it. It has a Wi-Fi chip inside it. So what I will do today, I will connect the sensor with this IO pin. And then I will connect as a actuator, I will connect now LEDs, and I will try to show you the sense the data and then sending the data to the cloud. And then I will also show you how to send the signals to the actuators by glowing the different LEDs, like red, blue, and green, different color LED. So this is actually Node MCU device. This is a ESP32 device, slightly higher version of Node MCU. This is costing around 500 rupees. But this device is having more capability, like it has a Wi-Fi as well as Bluetooth, both are there inside this device. This Node MCU is only having a Wi-Fi inside it. And this is having a Wi-Fi, Bluetooth, and microcontroller. So this is known as ESP32 device. So both the devices are very good devices. And those who have a old version of Arduino board and want to connect with a Wi-Fi, then this is a simple small board, Wi-Fi board is available, which you can use to connect a simple Arduino board to the Wi-Fi to make it IoT compatible. Otherwise, normal Arduino board is not IoT compatible, as it's not, you cannot connect it with the internet. So, but if you use this small board, this is very useful board, which you can use to connect your Arduino with a Wi-Fi. This is a Bluetooth module. So if you want to control the devices locally within a room, then this Bluetooth module is very, very useful. So your mobile phone is already having a Bluetooth inside it. So if you connect this Bluetooth with our hardware like Arduino board, then you can connect, you can control the Jetson Nano. So this board is a very, very useful board, advanced version of Raspberry Pi. It's having more capability. So those who want to run the algorithms like machine learning algorithms, which is more it requires more computation, because Raspberry Pi, if you perform the more computation, it will become hot. You know, this processor will become very hot. So in that case, this Jetson board is good. It is also, you can see heatsink is available here. So even if you do the more computation, even if the processor will become hot, then this heatsink will dissipate the heat to the environment. It is also having a Ethernet cable, USB ports, HDMI cable, all the things available in Raspberry Pi is also available in this Jetson Nano board. So this is also, we can say, a small computer. Simply you have to attach monitor, keyboard, and mouse with this. Then it becomes a computer. Then this device is known as a LoRaWAN module. LoRaWAN module is basically using Wi-Fi connectivity for wide area. So if your distance is within 500 meter or kilometer, then LoRaWAN is useful, because all this device Bluetooth is the distance is around 10 meter within a room. This Zigbee we can use up to 100 meter. So if you want to go beyond that, then the LoRaWAN is there. So if you have a wide entire campus is there and you want to connect it, then LoRaWAN will be useful. For that, this module will be useful. So ultimately, the sensors and actuators. So we have a different hardware like Node MCU, Raspberry Pi, Jetson Nano board, and all that, Arduino BLE Nano and everything. But these alone devices are not useful. You have to connect sensors and actuators with all these devices. So we'll be using transducers. So transducer is basically a device that converts one form of energy into another form of energy, and special types of transducers which are used to sense the physical environment quantities known as sensors. Right. So we'll be using a few sensors. I will try to, okay, let me start my video. I will show you. I don't know where. how to minimize these. I'm more comfortable with MS Team. I'm using this first time, so I will try to minimize and try to. So I mean, whatever I am showing is visible to all of you. Is it visible?
No, sir, only slide
The
is
white
visible.
device.
No,
white
sir.
device. Okay, it's not
Ah,
visible.
yes,
So what
sir.
I will do? In my camera, I think. Also, what I will do, I will start my internal camera and then I will try to show you. That will be better. Okay, let me start my camera here. Okay, I will connect another camera because it says that it is using only camera already. Okay. I will switch to this camera. I think now it's available.
Yes, sir, it is visible.
Yes, sir. Now it's
This is
visible, sir.
the DHT sensor, digital humidity temperature sensor. Then this is actually a PIR sensor. So this PIR sensor is having a 3 terminal here available. VCC ground and data is available. This one is a heartbeat sensor. So you can record the heartbeats with the help of this small sensor. Then in this board, actually, there are different sensors are mounted on that, like LDR is there, light dependent register is there, LM35 temperature sensor is there, then TSOC infrared sensor is there, then buzzer and push button switches and some LEDs are there. And if you want to simulate some sensor, then there are 2 ports are available here. These 2 ports are there. So just variable registers are available, which we can use to simulate any sensors, which if you do not have any sensor available with you can use it. This is prepared like a level sensor. So different wires are put at different distances and we can insert it into the tank. So it's a very simple homemade water level sensor is there. So we can use different sensors, which are basically transducers, gets the physical quantity, convert that into the electrical signal, and then we interface with our hardware. So at present,
Sir, you are not audible, sir.
I am not audible. Okay, am I muted?
No, sir, it is okay.
No, sir.
It's audible. And now I think slide is
Yes, sir,
visible
now
again.
Yes, sir.
Sensors and actuators is visible, right? Okay.
Yes.
Yes, sir.
So a few examples of the sensors which I have shown. So ultimately it will capture the environmental quantity and convert it into the electrical signal. And then we will connect these signals with the ADC input of our hardware. There are special types of transducers which are responsible for moving and controlling mechanism of a system, which is known as actuators. So we have a DC motor, stepper motor, then relay, solenoid, solid state devices. All these are the actuators, which basically change the environmental condition. So in one way, we are monitoring the environmental condition. In another way, we are changing the environment condition with the help of the actuators. And controlling device is a brain of system actually, right? So it's controlling devices are basically our node MCU, Raspberry Pi, all are known as a controlling devices. And these devices will take this data from the sensors, take the decision. So we will write some program, it will take the decision, and based on the decision, it will activate or deactivate the actuators as and when it is required. So ultimately 3 things, sensors, it will provide the data to the controlling device will send this data if it requires to internet, or it can send within a room or within a campus. So it depends whether you are using Wi-Fi or a Bluetooth or a LoRaWAN, or you are using a 4G, 5G, whether you are using satellite, fiber optic, depending on that, your controlling devices will send the data, and also it will send a signal to the actuators to control the ambient positions. So this is entire representation, whatever I am talking about. So we have a real world physical environment, which will be sensed by the sensors. It will be given to our digital hardware, which is also connected with the internet. And after that, it will take the decision and send signal to the actuators, and actuators will control the real world physical environment. So actuators is basically taking electrical input and turns it into the physical action. Exactly reverse than the sensors. So sensors will take the physical data and convert it into the electrical signal, while actuators is doing reverse. It's taking electrical input and turns it into physical action. So actuators are useful to manipulate the physical environment. So with your hardware, you have to connect the sensor also, and you have to connect the actuators also. And apart from that, hardware is also connected to the internet, so that all of these jobs you can do remotely from anywhere from the world. So ultimately, in a sensor layer, we are having a different sensors like GPS. As I told you, the first layer is a sensor layer. The GPS sensor, electromechanical, photoelectric, RFID, gyroscope, electromechanical, different sensors are there. It collects the data from the physical world. Our smart devices are integrated with the sensors. So sensors alone are not smart, but when we connect the sensor with our Node MCU board, or when we connect it to Raspberry Pi, or when we connect it with the Arduino Nano board, it becomes smart, because now it has got the connectivity. So now that simple dumb sensor becomes a smart sensor. So information like temperature, humidity, pressure, flow, air quality, motion detect, acceleration, vibration, etc. are captured and transferred to the digital world by smart sensor. And for asset tracking, people are using GPS. Yeah, in this Sunday, I was in a NEET exam. So in a NEET exam, I collected the trunks from the bank. So all the trunks were having a GPS in that. So, after collecting the trunks from the bank, whether it has reached to the proper destination or not, it was properly tracked by the system, NTA, National Test Agency. So I was really impressed by that system. And it was also having a timer inside it. So automatically at 1:15 p.m., automatically, digital lock which was provided on that trunk was open. So before 1:15, even if you try to open it, it will not open it. At 1:15, automatically it is open. So that's thanks to all these IoT systems, and because of that, it was possible. The wide variety of sensors are available, and sensors are selected based on the application. Wide variety is available. You have to select the sensor based on your own application. So if we look into the detail of classification of sensors, then it can be classified based on the detection principle, like different sensor have a detection like electric sensor, magnetic sensor, electromagnetic, acoustic, chemical, optical, heat, temperature, mechanical, radiation, biological. Those who are from the physics will be able to know the basic principles, how it is working actually. So based on the detection principle, sensors are classified. Sometimes based on the physical law involved for its operation, like some sensors are photoelectric sensors, magnetoelectric sensors, thermoelectric, photoconductive, photomagnetic, thermomagnetic, thermo-optic, electrochemical, magnetoresistive, photoelastic. So these are the different. This classification is basically how it operates actually, which physical law is there behind operation of this sensor. And some classification people are doing based on the specification, how accurate it is, how much sensitivity is, stability, then response time, then hysteresis. Then what is the frequency response of that sensor? What is the resolution? What is the linearity? What is the conduction material useful in that sensor, and at what temperature it can work? So all these are the specification, classification based on the specification. The sensors can be classified based on application also, like agriculture, automotive, civil engineering, domestic appliances, commerce, finance, environment, meteorology, security, energy. So there are a wide variety of applications are there, and based on the application also we can classify the sensors. And some sensors may not be able to convert directly into physical quantity into measurable low power electronic signal, but it requires a multiple conversion in between. So sometimes you require operational amplifier, you require a differential amplifier in between before you connect it with the digital hardware. And other sensors are coming, like which I have shown, that DHT22 sensor, which provides you a digital data directly. Right? So this digital sensor will provide the digital data directly. It's very easy to connect with our microcontroller or IoT embedded devices. And all calibrations and conversions are done internally in this type of sensors, digital sensors. Right? So there are analog sensors available, digital sensors are also available. A digital sensors will give us the data directly in a digital form. Then another classification can be active sensor and passive sensor. Active sensor actually requires the external power to operate, while a passive sensor doesn't require any external power. It generates its own electric signal, doesn't require any external power source. Like for example, thermocouples, if you take magnetic microphone, if you take piezoelectric sensors, then this doesn't require any external power. So it is a passive sensor.
Excuse me,
And,
sir.
yes, please.
Excuse me, sir. I think active sensors should not require external power. That is the passive sensors that require external power.
Actually, passive means doesn't need any. Let me search into Google. Let's clarify it now itself. Let me search it into Google. So Google will give us a reply immediately.
Passive elements are those elements which doesn't.
This Google screen is visible to you.
Yes, sir.
Yes, sir. Yes, sir.
An active sensor is a sensing device that requires an external source of power to operate. So if Google says that active sensor requires external power. And now let me put here passive sensor. The passive sensor is a device that detects and responds to some type of input from the physical environment. Right? So, so looking at the device, it seems that passive sensor, actually we are not connecting any external power source with those sensors. So that's why, but I think Google is also saying the same.
Sir, it will be more clear if we see the difference. I think I'm an electronics teacher. I am just teaching all these things. Would you please check it again? Okay, that's okay. Just let it be, sir. Okay, I'll just adjust.
So ultimately,
Okay,
see, there are sensors with few sensors require power and few sensors doesn't require power. That's only ultimately. So suppose if you want to use thermocouple, if you want to interface thermocouple with hardware, then it doesn't require any external power. It generates signal itself. Piezoelectric will also generate the signal itself. Like microphone, there are different microphones. If you use carbon microphone, then you require external battery for that. But if you are using magnetic microphone, it doesn't require any external battery. Then classification, again, context-based sensor or non-contact-based sensor. So in a contact-based sensor, you require a physical contact like strain gauge, temperature sensor, where you require to connect it physically. Non-contact sensors are basically optical sensors, so magnetic sensors. It doesn't require a physical contact. Infrared thermometers, like in COVID-19 situation, we used it to measure the temperature. It doesn't require any contact. So contact sensor and non-contact sensors. Then another classification is absolute sensor, then relative scale sensors. This is one more classification of the sensors. I will not go into much detail. Then LM35, today I will demonstrate if possible this LM35 sensor with our hardware. It's a very simple sensor, semiconductor sensor. Its operating voltage range is 4 to 20 volts, and operating range is minus 55 degrees centigrade to plus 25 degrees centigrade. Accuracy is 0.25 degrees centigrade, and sensitivity is 10 millivolt per degree centigrade. Analog voltage is pin 2 of LM35 need to convert that digital with ADC. ADC reading needs to convert into temperature degree centigrade. That means the output which is coming in voltage will not be useful to us directly. What we have to do, we have to do some kind of, we have to use some formula there to use that voltage. So for example, this ADC is giving us, it's visible, the slides are visible and one audible.
Yes, sir.
Yes, sir.
Okay. So suppose if you are getting some output data from here, and suppose if you are using 3.3 volt as a reference voltage in your microcontroller board, then this 3.3 volt, and if you are having a 10-bit ADC there, 10-bit ADC means total number of levels are 1024. So 3.3 volt divided by 1024, that will be the resolution of 1 bit. And then after, if you want to convert this into a degree centigrade, then you have to divide it by 10. Because this is a 10 millivolt per degree centigrade. And what we want at every 10 millivolt increment, we want a rise of 1 degree centigrade. So every time your reading should be divided by 10. And then this also 3.3 voltage, and whatever we are getting here in the millivolts. So you have to also multiply this by 100. Then this will be converted into the millivolts. So this millivolt divided by 10 divided by 1024, that will become our resolution. So this formula we have to use to convert the voltage into the degree centigrade. So this I will show you in a program also. Then there is one more sensor which is also very useful. This digital temperature sensor, DS1621. It provides a temperature output of 9 bit. Operating voltage is 2.7 to 5.5 volt. Operating range is again the same as the LM35, minus 55 to 125 degrees centigrade. Accuracy is slightly lower than the LM35. It is 0.5 degrees centigrade accuracy. Address pins are available. A0, A1, and A2 pins are available. So you can connect multiple sensors with the microcontroller. So we have a SDA and SCL available. SDA means serial data, and SCL means serial clock. So these two signals are available with us, which we can connect. So our all the board, Raspberry Pi, Node MCU, Arduino, all boards are also having SDA and SCL available in that. So which is a kind of a communication known as I2C communication, inter-integrated circuit communication, which is having these two pins are available in that. So we are using I2C communication to connect this temperature sensor with our hardware. This is one more sensor, DS1820. I will not discuss this in a length because I have to demonstrate a few more things to you. So just quickly I will show you all these sensors. This is a body temperature sensor which is useful for health application, because body sensor requires a more resolution in this range, 37 degree to 39 degrees centigrade. If you convert that into Fahrenheit, it will be from maybe from 95 to 105 range, and accuracy is 0.1 degree centigrade. So more accuracy in our range actually, in which we are interested. It is a 16-bit, and then it also provides the I2C interface. Right? So whenever you are using 16-bit ADC, you can see the resolution of ADC is very good, 0.00039 degrees centigrade. So that is a very good temperature resolution we are getting in this case. So in a ADC, actually, whenever you increase the number of bits, you will get a better accuracy. Then this is a proximity sensor.
Sir,
Yes, please.
so the sensors we are talking about, so these are the active sensors or passive ones?
And some of them are active and some of them are passive. For example, this proximity sensor is the active sensor. It requires the power supply. Right? So if you are talking about thermocouple, then thermocouple is a passive sensor. This sensor, is body temperature sensor, is again active sensor. It requires the power supply because operating voltage is written here. So this power supply we have to supply, and you can see in this VDD is here written. So VDD, that means at this point actually we have to connect a power supply, and here we have to connect ground. So the passive sensor you can easily identify that it doesn't require, it doesn't have a power pins at all. So you will identify that it is a passive sensor, doesn't require any external power. Like in thermocouple, only 2 wire is coming out. So 2 wire is simply a data. So you don't give any kind of power supply there. So even if LM35 is also active because it requires the power supply. You can see pin number here. The 1 number is output and 3 number is ground, and 1 number is sorry, this 1 number is the power supply, 2 number is ground, and 3rd one is ground. So this power supply you have to apply to this sensor, so that's why it's the active sensor. Ultrasonic distance sensor, again, if you want to measure the distance and you want to send the distance to the remote device, you can use this ultrasonic sensor, and it works on principle of sonar or radar. It emits the pulse. If object is there, the pulse will be reflected back, and based on the timing of between the transmitted pulse and received pulse, we can calculate the distance. So we have normally if a pulse of 10 microsecond or more is given to the trigger pin, the 8 pulses of 40 kilowatts frequency will be transmitted. And then after we will receive the pulse. So on echo pin we will receive the pulse, and the distance can be computed with help of this formula: duration, that is in microsecond, multiplied by 0.0133 divided by 2, because it is a to and fro. From transmitter you are sending the pulse, and from the object it will be reflected back to the receiver. So it is a to and fro, so it is divided by 2. So that will be your distance. So here is your sensor, and here is your object is there. So to measure the distance, we are using, because the ultrasonic wave will transmit at the rate of 340 meter per second. And when you convert that into inch, you have to divide it by 2.54. So that's 133. And you divide it by 2 because you want to measure the distance. So we have to divide it by 2. We can use this formula in our program to get the distances from the ultrasonic sensor. This is a diagram which shows the different types of sensors like color sensor, gas sensor, LDR, thermistor, soil moisture sensor, humidity sensor, touch sensor. All these sensors are shown here. Different types of sensors are available, and all sensors are available online easily. And it's all are low-cost sensors. So you can ask your students to purchase it at home. They can do their experiments. They just purchase one node MCU board, then few sensors out of it, and then they can perform the IoT experiments. So your IoT lab will not cost much if you want to perform some experiments. And although in COVID-19 situations, if parent has not given the consent and if they are not coming to the colleges, they can perform this experiment at home also. Just you can guide them remotely and they will perform experiment at home. Few more IoT devices and sensors are shown here. This is a door sensor. So you can monitor at what time the door was opened and what time it was closed by putting this door sensor here and connecting this door sensor with our IoT hardware. PIR motion sensor, that is whenever somebody is there inside the room, automatically PIR motion sensor will detect and give a signal. So ultimately, it will detect the presence of human being. Mostly, it's based on the principle of infrared. So it detects. So if you want to enter, if you want in a home automation, whenever you enter in a room, automatically the lights will switch on. That type of applications student can build. or whenever somebody is entering inside the home, then email will be sent and SMS will be sent. That type of application also can be prepared. So suppose if you are going in a tour and normally your home is locked actually, but whenever somebody is entering inside, you will automatically get the notification that somebody has opened the lock and some movement is there. Then after you can switch on the camera and you can also actually see who is there. That kind of application we can build with the help of IoT devices. This is the device which I have already shown to you. Yes, please.
Sir, for door locking, we have to use capacitive sensor, sir.
You can use
no
either
sensor.
capacitive sensor or this type of whatever I have shown here is a magnetic sensor. But you can always use capacitive sensor or simply that switch also you can use. So whenever
Okay, sir.
you shut the door, the contacts will come and then. So any kind of sensor you can use there.
Okay, sir.
Then smoke sensor to detect the gas leakage and all that. We can use the smoke sensor. Capacitive touch sensor. But whatever the sensors which I am showing here, mostly all these sensors are kind of active sensor because all requires a power supply. Doesn't require much power supply and much current. Only it requires 3.3 volt and few fraction of milliampere current it requires. Doesn't require much current. Then light sensor is there. And this flex sensor, you can see flex sensor is a passive sensor, doesn't require power, only 2 pins are coming out. Then this ultrasonic sensor, then this is the camera. Sorry, not this is not camera, this is the camera. This is a ping device actually. This is ultrasonic sensor which to measure the distance. Similarly, this is a ping device. This is also useful to measure the distance. This accelerometer to detect the movement in X, Y, and Z direction. Then very important thing is IoT protocols actually. You have a sensors, you have collected the data, but then how to send it to the cloud, then there are protocols are there. Out of them, most widely used protocol is this MQTT protocol. Other protocols are also there at application layer. Then there is a transport layer, those who are in computer very much familiar with the TCP protocol and UDP protocol. At network layer, there are IP version 4, IP version 6, and then 6 low PAN protocol. Then in a link layer, there is the Ethernet protocols and then Wi-Fi protocols are there. So these are all protocols are useful for IoT because we want to communicate sensor data to the cloud. Further, all these protocols, particularly for IoT, is written here. And very famous is again this MQTT protocol people are using. There is a website also, you can search for that website MQTT where all the detailed information is given in that. COAP is also very popular, but most popular is the MQTT protocol. So ultimately, why this IoT is booming nowadays? Because we have a now high-speed internet connectivity is available to us. So because of that, now internet is not a problem. So that's why this major driver for the IoT. Availability of Wi-Fi enabled devices. Many Wi-Fi enabled devices are available. Growing smartphone adoption. That is one more driver behind the IoT applications. And very important non-technical reason is increase in laziness. People are becoming lazy day by day. And that's actually people want home automation, want to do everything remotely. That is also the one non-technical reason for IoT applications. Availability of low-cost Wi-Fi chip, which can be attached with the sensor to make it smart. So low-cost chip like small ESP8266 chip is available with 100 rupees only, which you can connect with the devices. Arduino Nano type of a board or a not MCU boards are available at 300 rupees only. So it's low cost devices are available. So that is the major driver for that. Low cost and small size embedded chips are available. So these are the main drivers for the IoT. Now let's look at one particular device so that I can show you the demonstration and programming. I will be using today Node MCU device. It's looking like this here, and if you can see the camera, I am showing it to the camera also. That camera video is available. Let me zoom it so that it becomes available.
Yes, sir.
It's availability. Do this. So this is a Node MCU board. So I will be showing that board today. We try to show it. So it is the Wi-Fi support of 802.11 BG and N standard. Operates at license-free band 2.4 gigahertz. It has one analog input. So as I told you, it has a one ADC input. If you purchase higher version, then maybe you will get a more number of analog input. 13 digital I/O pins are available, which is having alternate functions like USART, I2C, and SPI. That is serial communication functions are available. It has a USB micro USB port for a power. So this is actually a port where you can connect the your mobile charger cable to power this particular board. And it can support MicroPython, which is a subset of Python programming, as well as it can support the Arduino programming. So today we will focus on the Arduino programming part. Although we can program this board with help of a MicroPython also, but it may not be possible for me to show the demonstration today with help of a MicroPython. But I will show you the Arduino programming. This is the pin diagram of Node MCU board. As we can see here that different pins, GPIO pins are available. This analog pin is available to connect the analog sensor with this board. So I will connect all the sensor LM35 light, etc. All sensors. If I want to connect, I can connect with A0 pin. Then D0, D1, D2, these are the digital pins available in this board. D0, the name is a GPIO 16. So GPIO 16, so this pin can be referred as a GPIO 16 or a D0 pin. So both the names are given to that. Alternate functions are also written here. You can see this pin GPIO2, which is a D4 pin. Alternate function is a TXD1 pin. So it is a USART pin, UART pin, Universal Asynchronous Receive Transmit pin. So it will work as a transmission pin. So for a serial communication to transmit the data, also you can use this pin. So multiple functions are there. Either you can use as a GPIO pin. GPIO means general purpose input output, or you can use it as a transmitter pin. So different pins have a multiple functionality, and this is the pin diagram which we have to refer again and again to connect the devices. So, and if you do not have this board, and if you have an Arduino board like this, the Arduino board doesn't have a Wi-Fi functionality. So if you want to use Arduino for Internet of Things application, IoT applications, then you have to connect this chip. ESP8266 small chip is available. I'm also having that chip. I will show you. It. Yes, I have this board. It's visible. Small chip is there. So let me switch to that camera again.
Yes, sir. It's visible.
This small chip is there, which is having a connector, GPIO connector is there, and this is ESP8266 chip. So to compare the size, actually, what I will do, I will compare it with a pen. This is a pen and this chip, so you can easily recognize the size. Very small chip is there. So this chip we can connect with the Arduino board, and we can use this Arduino board for IoT applications. Because Arduino is very famous, and many of you must have used, some of your students must have used. It is very easy to program and very famous. So we can use it for IoT applications by connecting ESP8266 chip with this. So this is a connection diagram for that. Arduino, I think how many of you are familiar with this programming IDE, Integrated Development Environment? If you are not familiar, no problem. It is open source hardware. It's hardware and software, both are open source. So we can freely use, doesn't require any license. You are encouraged to improve it and share with others. And large number of well-wishers are available to help you throughout the world. So you just Google it and you will get the ready-made program for the Arduino. There are about 55 different Arduino boards. Actually, when I prepared this slide, it was 55. Now it must have increased, right? Because every day, number of boards are increasing. And there is a website for it. So always you can refer this website to download the Arduino IDE from this website. You can also order the board from this website. So latest software is available on this website. And what are the different types of boards are available also given in this website. So whenever I visited this website last time, there were about 55 boards were there. I'm sure now it has, it must be increased now. But once you refer it, you will find more number of boards in this. So this is the first typical Hello World program to simply test the board. So normally in a computer engineering, we use the Hello World program, right? But in a embedded systems or in IoT, we glow LED. Just we call glowing LED as a Hello World program. So this is a very simple program, which initially you can write and upload into the hardware and see whether it's properly working or not. So I will explain this program. I have declared one variable LED pin as an integer variable, and I have assigned value 2 to this because my internal LED is connected with a GPIO2 pin, which is basically digital pin 4, D4 pin, where internal LED is already connected. Then this is a setup. So in Arduino IDE, these are the two major functions. One is a setup and another one is a loop. So in setup, all initialization is done. Here pin mode, then LED pin, which is our pin number 2. We are declaring it as output because LED is output device. So we are writing it as an output. But suppose instead of output device, if we are connecting an input device to some other pin, let's say on pin number 3, if I am connecting some input devices like switch or a digital sensor, then I can declare it in this way, pin mode 3, input, where I am connecting this digital sensor. So if I am connecting actuators like a servo motor or a stepper motor or relay, solenoid, solid state devices or LED, all these are output devices. So in that case, I will write output there. If my device is an input device, then I will write input there. So it's very simple. So this setup will initially set up all the pins. It is basically a initialization. So it will initialize all the pins. Then loop is a simple like in a C language there is a while one loop. Right? So it is a very much similar loop like this while one loop, which will continuously run. Very simple digital write LED pin comma high. So this LED pin will become high. That means our GPIO2, which was there, whatever the device is connected there, will get the plus 5 volt supply. For 1000 milliseconds, for 1 second, it will get the active high signal. Then after digital write, LED pin low. So this GPIO2 will become low. And the LED is connected there, so LED will turn off. So it will just make the LED on and off at the interval of 1 second. So this is a simple program. This is very simple, so I will not demonstrate. I will demonstrate somewhat complicated program here. Right? So I will just skip this. So I think you understood this program or any doubt?
No, sir.
Okay, sir.
Got it, sir.
No.
So it is continuously working, right? It is infinite loop. It is just making LED high, low continuously. And nothing, it's not connected to internet. It is a simple, testing of the board. Then sometimes in Arduino IDE, normally useful for Arduino Uno, Arduino Mega, Arduino Nano kind of a board. But if you want to use the same IDE for a Node MCU board, then by default you will not be able to use it. You have to install the board using a board manager. And to install the board manager, this is actually a path you have to write at the section inside the files, and you have to go to preferences, and then you have to paste this link there, and then after you will be able to download the Node MCU board. So to search the Node MCU board, you have to write ESP8266 in the search box. So what I will show you that in Arduino IDE itself, so that you will get exactly idea. You have to go to file. This file menu is visible. File, then preference, and then additional board manager. Here you have to paste that link. Then after, this board will be available to you. Otherwise, this board will not be available to you by default. So just you write this link here, and this link you can easily find out with the help of Google. Link to add the Node MCU board in Arduino. If you write that much in a Google, you will find this link immediately, right? And then you have to copy this link and paste it here. And then after, whenever you, this is basically Arduino IDE, where we will be selecting different boards. So if it is visible to you, I have selected here in a board section, I have selected Node MCU 1.0. Different boards, entire list is given. Out of them, I have selected Node MCU 1.0. Is it visible?
Yes, sir.
It is visible, right? But this Node MCU will come only if you add using a board manager. By default, it will not be available in Arduino IDE. So you have to start this board manager. You have to write, you have to search for that ESP8266, and then after only it will install. So by default, it will not be available. So for example, I am writing here ESP8266, right? And then I will try to search it. So it's giving here ESP8266 by ESP8266 community, and these are the supported board for it. So at present, I have already installed, right? So it is coming installed. If it is not installed in your system, here you will get it. So simply you have to click the install button or Arduino IDE. But by default, it will not be available. So these two steps simply you have to follow. What's two steps? You have to copy that link and paste it into the file preference, and then after you have to search for this board and then install it. So this only two procedure is required, small procedure is required before you can actually use Arduino IDE for it. Okay, any doubt, any questions up till now? You have to copy this link and paste it into the file preference, into additional board manager line, and then in a board manager you have to write ESP8266 and install simply. Then that board will be installed. Okay. Now let's look at one more program. We have seen that you can send the signal to the output device, high and low signal to the output device. Similarly, you can also read the signal. If you have a digital sensor, you can use command digital read. Digital read. Will be small, okay, small. In this first D will be small. Digital read, R will be capital. For it to write, it is digital write, and to read actually it is a digital read for a digital sensors. And for analog sensors, actually, it is analog read, which is the command written here. So for example, here I have connected one LDR, and I'm taking output from the LDR, and there is a register of 100K is there, plus 5 volt is given to that. So whenever light will fall on the LDR, the resistance will decrease and my output voltage will reduce. And during the dark condition, the LDR resistance will be high, so my output will increase. So depending on the intensity of light on the LDR, I will get a different output. And that light output actually I want to read and want to measure. So in the setup loop, actually LED pin is output, so where my internal LED is connected. Locally I want to monitor the data, so serial.begin 9600 is the baud rate at which I'll be getting the data. So this is my setup initial. Inside the loop, light data equal to analog read light pin. So my light pin is actually 0, which is the analog input A0 pin of my node MCU. I'm reading the data. I'm printing the data locally. And if my light data is greater than 500, I want to blow the LED. And if my light data is less than 500, I want to turn off the LED. So this is for applications where actually automatic strip light control. Whenever there is a dark condition is there, automatically strip light will become on. Whenever there is daylight is there, strip light will become off. That kind of application. So ultimately, we are getting data from the sensor, and based on the sensor input, we are controlling the output device. In our case, we have taken the LED. So is this program clear or any doubt? Okay, should I demonstrate this program on Node MCU?
Yes, sir.
Okay, I will demonstrate this program on Node MCU locally, right? So let me open that program here. So I have some program here, LDR sensing. I will open that. That will be the same program which I was showing to you in PPT. So this is the same program I have written here. Light pin equal to 0. So ADC input of node MCU, setup, and then serial communication. And I'm reading the analog data and simply displaying the data locally. I'm not sending it to any cloud and all that. Later on, I will also show you that. I will now connect my node MCU board with the laptop. So I will connect it. Some buzzer tone was there, and then after I will get that board here. So I can see here port is a COM3. So COM3 port, communication port, is assigned for the node MCU board actually at present. That board is assigned. Now my board is connected with the system. Now what I have to do, simply I have to click on this upload button. When I will click on this upload button, the program will be uploaded into the node MCU board. At present it is compiling the sketch. It is compiling the sketch, and then after, once the compilation will be over, the program binary file will be generated, H file will be generated, and that H file will be uploaded to the hard. So we can understand the serial load begin and light data, etc. Machine cannot understand. So this will be converted into zeros and ones, binary file, and then it will be communicated to the hardware. I will also show you hardware in parallel.
Excuse me, sir.
Yes, yes, please.
Which software you are using, sir?
I'm using Arduino IDE. Just you can you will get it post on a website. Just let me show you that website also. I will write it here. Arduino.cc is the website for it.
Pardon, sir. Sir, please.
Is it visible? My screen is visible. My screen is visible.
Yes, sir. The screen is visible, sir.
Yes, sir. Yes, sir.
So I have written that URL here, https www.arduino.cc. So this is the actually website for that. And from this website, you will be able to get the software here. Software is written here.
Hello.
Ajit,
Hello.
Ajit, please. Please बोलिए. Is there any questions?
Sir, I have one question. You
Yes,
said
yes,
that using IoT device, we can send the
Yes.
message on that Twitter account. Okay.
Yes,
Is
yes,
it
we can
possible?
send it, sure. Yes.
Is it possible, sir? Can you send the message on WhatsApp?
WhatsApp is not possible because they are not providing that credentials to us. But you can Google. Somebody has done it, crack it out, but I could not do it. Someone has done it. So if you Google it, that sending the data from Node MCU to WhatsApp, somebody has done it, but I could not do it up till now. So I'm not sure about it.
Okay. So again, one question is that can you interface GSM model to the Node MC board?
Yes, because GSM module is having a TXD and RXD pin, and our Node MC is also having a two ports, TXD0, RXD0, TXD1, and RXD1. So two serial ports are available, so you can easily interface GSM module with it, no problem.
Okay, sir. Okay. Thank you, sir.
So I think whatever I am showing in the screen is the Arduino website, from where you will be able to download the Arduino IDE, which I am using at present to show you the demonstration, right? And it is free of cost, license-free software available, which your students also can download and use it. And a lot of support is available. The very good thing about this Arduino support and documentation is available. Hardware is showing here hardware. Arduino products are here. You can see IoT products are also available here. Different IoT products are available here. So whatever Arduino Nano 33 IoT I was talking about, all these boards are available here. And you can directly purchase it. You can give your location and then you can purchase it from the site itself. So hardware will cost you, software is free of cost. So if you want to purchase the hardware, you have to pay for it. But the software is free. And also, if you don't want to purchase the hardware, you can prepare it yourself because it is open source. So there is no license, no patent for it. You can prepare it yourself. That is the beauty of Arduino. So I will just you can see done uploading means this program is uploaded. Now I will just click on the serial monitor. Then one serial monitor will open. I will select the baud rate from here instead of 115200 is at present is. I will change it to 9600. And you can see some readings are coming here. This is the light data readings. So all these readings I am getting from the LDR. Here I will show you. Is visible to all of you. This node MCU board and this small board which is having LDR in it. This is small board in which there is one LDR available. I will put finger on it. Now you can see my the reading has increased. Now it is in the range of 900. Because I put my finger on that, the light is not falling on the LDR, the resistance will increase, so voltage output will increase and corresponding reading will increase. If I remove the finger, then my reading will reduce. Now it is 685. If I will focus to LDR to the window, now further it has reduced. Now it is in the range of 300. If I put finger on the LDR, it will become in the range of 900. Right. So by different light intensity, my readings will change. Is it visible? Whatever I am doing here is visible to all of you.
Yes, sir.
It's visible. So this is the light sensing, and we are displaying it locally. We are not connecting with the internet. So I want to show you some demonstration related to internet also, right? So this is my local actually one. Now let me open the another program in which we will be transmitting to the UB.cloud actually, right? So all of you can also open your account in a UB.cloud. As program, this light sensor data I have uploaded into the UB.cloud, which we can monitor anywhere from the world. Right? So the time is limitation is there, but I will need only 5-10 minutes. Is it okay, madam? Fine.
Okay, sir.
Already, maybe your lunchtime or but sorry, I was slightly late, but I will take only 5-10 minutes more. So
Yes, sir. Yes,
I have
sir.
included
हेलो फ्रेंड्स, आपको सर की आवाज आ रही है क्या?
No, ma'am.
No, madam.
No, ma'am.
ओके,
My
नहीं आ
screen
रही।
is okay.
नहीं आ रही मैडम आवाज।
वेट वेट वेट। हेलो
Hello. Hello, ma'am.
यस यस, प्लीज वेट, सर इज चेकिंग हिज कनेक्शन।
Okay, ma'am. Okay.
So I will upload. I have already uploaded this program meanwhile.
सर काइंडली शेयर योर स्क्रीन।
Yes, yes, I will share it again. Okay, now screen is available?
नॉट येट सर।
Not yet. Okay. Okay, now is available or not? Still not available. Is it available now?
नो
No, sir. Yet not.
Maybe due to network, I think it is happening. Share content. I am using the same thing again. Share content, screen one. I am, using the same steps which I was using previously.
यस सर।
Still, it's not giving. Should I disconnect and connect it again? I will disconnect and then again we will connect.
ओके
We will leave
ओके
the
सर।
meeting. Okay. At present, my sharing option is disabled. I'm trying to share the content, but it is disabled actually. Now it is enabled. Okay.
Yes, now it is sharing, sir.
Now it is there. Okay, just
Yeah.
fine. Now you can see I have connected the serial monitor, and it is saying me some messages, publishing topic light, and then JSON data it is saying the value 402, 403. All these values are being communicated to ub.cloud here in my dashboard. You can see 403 is also available on this widget here on a ub.cloud. So data is being sensed locally by Node MCU board from the LDR, and then it is communicated to ub.cloud. If I put my finger on the light sensor, the data will change, and the similar change will be reflected here in a widget. You can see 810 now it is showing. If I remove my finger from the light sensor, the light intensity will fall into it and the data will reduce. So is it visible to all of you, or whatever I'm showing on the gauge widget?
Yes, sir.
Yes, sir.
So in this ub.cloud, we can also add more widgets. Here, different widgets are given for a graphical representation of the data. Let me take one more widget here. Let me take this tank actually. So this tank variable I can add here. So this is actually the range value is from 0 to 100. My ADC data is in the range of 10 to 1023 because I'm using 10-bit ADC. So entire range is 0 to 1023. So I have changed this range here. And then I'm adding the variable. I have different variables like humidity, temperature, light switch, and light. Out of this, I'm using LDR as a light variable. So I will define this light and attach this light variable with this particular widget. After attaching it, this tank widget is available. Now it is also showing the 564 light value. When I will put finger on the LDR, the value should increase. Now it has become 840. So both the widgets are showing. So it is a graphical representation of the data. And on the web browser, it is showing as well as I will show you my mobile phone, where also we will get similar kind of application, ub.application, and it will be available in that also. So in my mobile phone also you can see these gauges are there. Of course, the numbers are reversed in that because of the mirror image. But you can see this ub.mobile application, this sensor data you can monitor anywhere from the world. Even if I am coming tomorrow at Nagpur, then my local sensor data will be visible at Nagpur also because I am transmitting this data to the cloud. Many more things to discuss, but this time is not permitting. So I think we will stop our discussion at this point. I think if you have any further doubt, you can ask. Thank you very much to HRDC Nagpur for inviting me and to share my technical knowledge with all of you.
Thank you so much, sir, for your wonderful session with lot of demonstration as well. Friends, if you have any query, you can discuss. Any question?
Please put your contact details and mail ID so that we can communicate in further.
Okay, so what I will do, I will go to the slide, directly to the last slide, and I will put my contact details there. Or in chat box, should I put it in chat box? Okay.
Sir,
My email
I
ID.
share, yes, email ID you please share. Actually, I shared your number in our WhatsApp group of this course.
Okay. So this email ID chvithalani@gcrajkot.ac.
Yes. Any more question? Sir, I think there are no questions now.
No questions.
So
Okay,
on behalf
thank
of all the participants and from HRDC Nagpur, I extend my hearty thanks to you, sir, for spending your valuable time and giving your wonderful demonstration come lecture for all the participants, sir. Thank you so much, sir.
Okay, thank you.
Thank you,
very
sir.
much.
Thank you.
Yeah.
Friends, now we will take our lunch break and it's quite late, but you join our meeting by 1:15. 1:15 we will start our next session. Okay? Instead of 1 o'clock, we will start our session by 1:15.
Okay, okay.
Yeah.
Okay, goodbye to all.
Good day,
Thank you,
sir.
sir.
Good day, sir.
Thank you,
Thank
sir.
you.
Thank you, sir.
Thank you.
Madam, sir, we will leave.
Thank you, ma'am.
Or we will continue.
Sir, you don't leave the meeting. Stay connected,
Okay.
but come back by 1:15.
Okay.
Okay.